5.3, predicting reaction products. We're going to be looking at the 5 different types of reactions and trying to see if we start with reactants, can we predict what possible products will be shown. So first we're going to start with synthesis. So this is, again, we're looking at 2 separate reactants, and most likely they're going to combine together and make a synthesis. So when we think about this, we've got to figure out, is it possible for these 2 things to combine? For example, you've got chlorine and you've got sodium. You have a nonmetal and a metal. They can combine to make a ionic compound. So we need to make sure that we have our periodic table out and handy at all times, because we're now looking for the charges. So we've got to remember, okay, if it's in the first column, for example, sodium, it has 1 valence electron in its outer shell. So that 1 electron can be lost and become a positive charge. So remember here with the electron configuration, this helps us out. And so notice again, it can be a, I don't like how it says -1, it's supposed to be just a positive one, right? And then if you get chlorine, we're looking at the fact that it has 7 valence electrons in its outer shell. So again, it's going to gain the 1 and become a -1 charge. So sodium with a positive 1, chlorine with a -1, that's the transferred electron, and it will bind ionically. So if we see here, we have sodium again, +1, chlorine makes -1. Even though there's 2 of them, each chlorine atom makes a negative charge. So I don't want to see NaCl2. That's not correct. You have to balance out the compound based on its charges. Then you can balance the atoms. So let's look at prediction 2. So here we're talking about copper. Now, why is it +4? Well, I try to hint to you over here, the product is going to be a copper 4 product. So start with the transition of copper 4+. Again, sulfur is in the 6th column, so it's got 6 valence electrons. It wants 2 more to be satisfied in its full shell, so 2-. Again, think about 4+ and 2-. How do those balance? Well, it can't be one of each, so we need to double the sulfur to balance the copper. So again, 1 copper at charge of 4 plus 2 sulfurs at charge -2, that will balance to 0. Again, we do not write the charges in the compound, we simply just write the subscript of how many are bonded. So our copper plus sulfur gives you copper sulfide. In this case, it would be copper 4 sulfide. You'd have to use the Roman numerals to explain the charge of the transition metal. And then you'll go ahead and balance. Since we have 2 sulfurs in the product, we need 2 sulfurs in the reactant, and then we are done. Again, you're more than welcome to put a 1 in front of the copper and copper sulfide, but leaving it blank is fine. You cannot, however, put a 0. If you put a 0, that means it doesn't exist, and that's incorrect. So I'd like for you guys to try some of these. Again, if you found the sneak way of going and viewing, you can go to the next slides and see your answers. But again, I want you to practice them before you go look for the answers. Okay, so since I'm not there with you today, I'm going to go over this. You've got aluminum and you've got oxygen. Again, aluminum, if you need to, going back to the periodic table, aluminum has 1, 2, skip transition, 3rd column, so 3 electrons. Oops, sorry, go back. Okay, so aluminum has, so I can bring up the pen. Things in the way. Okay, so Al becomes a 3+ because it has the 3 electrons it will lose. Again, we're looking at the oxygen, but not the O2 molecule, just an oxygen atom, and it would have a 2- charge. So looking at this, okay, 3 plus and 2 minus do not balance, so we need to do the switcheroo. And this gives us Al2 and O3. So that will be your product. Now we look at balancing. And we have an oxygen is at 2 and oxygen on the right is a 3. That's more complicated. So balance that first. We'll put the 2, that gives us 2 times 3. Now notice this 2 is here is only for the aluminum, while this 3 is only for the oxygen. So I noticed some of you looked at like CO2. The 2 is only for the oxygen, so it's a carbon double bonded to one oxygen and double bonded to a second oxygen. So there's only one carbon. We just don't put the 1 because it's kind of redundant. So think about every number follows the element that it has. So going back here, we have 2 times 3 is 6 oxygens, so we need 3 times 2 to make it 6 oxygens. Now we look at the aluminum. 2 times 2, you have 4 aluminums, so we place the 4 in front. So our final answer, 4 aluminums plus 3 oxygen molecules give you 2 aluminum oxide ionic compounds. All right, I'll go through one more. Here you have magnesium and iodine. Okay, magnesium is in what column? It is in the second column, number 12. So magnesium has 2 electrons, therefore it will lose them and become a 2 plus. Iodine, just like chlorine and bromine and fluorine, are in the 7th column. So iodine will gain 1 electron and become a 1 minus. Since these are not the same, we'll need multiples. So you get MgI2. And we're making an ionic compound. We take a look at this and we try to balance. Since there are 2 iodines on the right, 2 iodines on the left, there's nothing that needs to be changed. There's 1 magnesium on the right, 1 magnesium on the left, nothing to change. So your balanced equation, I guess if you really want to, you can say 1 Mg plus 1 I2 forms 1 MgI2. But again, the ones in front are not necessary. Okay, up next, decomposition. Okay, decompositions, you're always going to start with one compound, and then it's going to create products. So when you see something that is simply just one thing, you kind of have to look at it and decide, well, how is it going to break apart? So here you've got this copper, carbon, and oxygen. Remember, you can only have positive entities and negative entities. Again, you have cations and anions. So if you think about here, you've got the difference of a copper and a polyatomic ion of covalence. So when we think about it, it's got to split between copper and the carbon dioxide. So, in this case, carbon trioxide or carbonate. So we have to think about, sometimes you may know it breaking down into 2 separate things, but we'll try to give hints if necessary. So when we look at prediction 1, you've got N2O. So in this case, it's going to break out, and you've got 2 different elements, so it kind of makes it easier, breaking into nitrogen and oxygen. Again, break your apart. Remember your Hofbrinkel. You've got to say it out loud 10 times, because if you just put a single N and a single O, then you're incorrect. And nitrogen, if you think about nitrogen, it has 5 valence electrons. So to exist by itself, it's missing 3. So in reality, you're going to get 2 nitrogens triple bonded to each other with its set of lone pairs. So this is where it exists naturally, with 2 nitrogens. It does not exist with all these empty spaces. I think once you figure out your products, then you go, again, always balance. It's a huge thing If you do not have balanced equations, our next unit will be really difficult. So just double check. 2 times 2 for nitrogen, that gives you 4 on the left. 2 times 2 nitrogen, 4 on the right. Again, there is no number behind the oxygen, so it means you just have 1. This 2 is not associated with the oxygen. It's nitrogen has 2, oxygen has 1. So there are 2 oxygens on the left, and then because the 2 is behind the oxygen, there is 2 oxygens on the right. Okay, prediction number 2. You're looking at nickel and oxygen. So again, break it up. But metals, since metals have the atoms all bonded with a sea of electrons, you simply are just going to write nickel by itself. It does not need any subscripts. And then again, oxygen is off wrinkle, so make sure it's O2, and then balance is necessary. Okay, so let's go through the first one. Again, we have silver and oxygen, so again, we're going to split. You've got silver, which again is a metal, so leave it alone. And then you've got oxygen, which is a Hofbrinkel, so O2. And then now that you have it nicely written, think about balancing. You've got 2 silvers, 1 silver, but you have 2 oxygen. So I think I would balance the oxygens first. So we're going to put a 2 here. Then that's 2 times 2. That gives me 4, and a 4 in front of the silver. And that is balanced. Okay. Aluminum bromide. You're going to split it. So you're going to have aluminum and you're going to have bromine. But bromine, again, is Hofbrinkel, comes as diatomic. So you simply write it as aluminum plus your Br2. You've got 2 and 3, so make sure to do the opposite. And you'll balance with the remainder of the aluminums with 2 on each side. Okay, so up next is combustion. Again, combustion, we're looking at a very specific double replacement or double displacement reaction, because the oxygen, again, binds to the carbon and it also binds to the hydrogen. Therefore, it's making not 1 but 2 products. So there's a double switching. Now, the front, the hydrocarbon, hydrogen bonded to carbons, that can change. But it must always have oxygen, because again, look here at the fire triangle. In order for fire to exist, which is again combustion, you have to have something to fuel, something to burn. So that is your hydrocarbons. Wait, sorry, trying to write with a mouse pad here. So CXHY. Sometimes we can add oxygens or nitrogens in there. We'll look at that later. But for the most part, we've got to make sure we know that the fuel is a hydrocarbon. So any amount of carbons and hydrogens bound together. You must have oxygen. Can't happen unless oxygen's present. That's how we break the triangle so we can put out fires. And then we have to have some kind of ignition source to get it started, enough energy to get the reaction started. And you will always, because oxygen binds with the carbon, you'll always make carbon dioxide. When oxygen binds with the hydrogen, you'll always make water. So please know, anytime you see hydrocarbon and oxygen, you will always make carbon dioxide and water. There's no exceptions. So when we look C2H6, we have a new hydrocarbon, but we again have oxygen. So what are our products going to be? Only water and carbon dioxide can be formed. There will be later in AP, you'll learn about incomplete combustion, but for right now, it's always going to be water and carbon dioxide. So we need to rewrite it with water and carbon dioxide as our products. Again, I'm okay if you put the CO2 first and then follow it with the H2O. That's also appropriate. So then now, once you have it rewritten, you try to balance. So I want you first to balance your carbons. So you put your 2 in front of the carbon. Then you balance your hydrogens. You put your 6. So 3 times 2 gives us the 6. And then next, you balance oxygen last. So we say, okay, there is 3 times 1. It's not 3 times 2. There's only 1 oxygen in water. So there's 3 oxygens here. Plus 2 times the 2. There's 4. So 4, 5, 6, 7. We have 7 oxygens on the right. Here we only have 2. So to think about what multiplication times 2 will give us 7. Well, if I need the 7, I'm going to write the 7. But then how do I get rid of the 2? Well, what divided by 2 can give me back to 1? So 2 divided by 2 would cancel out and you'd have the 7. So this 7/2 is what's going to go here. It's going to look ugly to start, but we'll fix it. So if you'll notice, if you take this whole equation and multiply it by 2, you're going to have 2 times 1 will be 2. The 7/2 times 2 will get rid of the denominator, and you'll have 7. And then 3 times 2 gives you the 6, and then 2 times 2 gives you the 4. This is what we want to see. A final reaction that has the lowest ratios of whole numbers. While the previous one with the fraction is balanced, it's just not what we want to finally communicate. So have your final answer be whole numbers and the lowest ratio. Okay, so up first we have C6H12O6. This is a hydrocarbon that has extra oxygen. Again, it's still a hydrocarbon. So we're just going to focus on, here's your O2. So we know it's going to make CO2 and H2O. And for our person honors chem, it's always be CO2, H2O, unless otherwise stated. But we're going to say complete combustion. It makes all CO2, makes H2O. So this oxygen will be split up amongst those carbon dioxides and waters. Okay, so now when we look at this, we're going to have to balance. So we're first going to do our carbon, then our hydrogen, and then our oxygen last. So carbon on the left side has 6. Carbon on the right side has 1. Hydrogen on the left side has 12. On the right side it has 2. Oxygen, please remember to keep these separate. We're not going to multiply both at the same time. They're separate compounds. So we have 6 plus the 2. And then we've got, again, here separated, 2 plus the 1. All right, so now we try to balance. Okay, 6 carbon, I need to multiply the right by 6. We're going to put that up. I'm not going to ignore the hard work I just did, so I need to come down here and multiply that by 6. Next, move to hydrogen. We have 12 and 2, so I need to multiply the water by 6. Again, I'm not going to ignore the hard work it just did, so we need to multiply the 1 times 6 for the oxygen. Right, now in oxygen, we're going to total 6 times 2 is 12 plus another 6, a total of 18, which means over here we need to have a total of 18. Okay, I already have 6. I'm not going to change my hydrocarbon because that will change how many carbons I have, how many hydrogens I have, so we leave that alone. Okay? So we're just going to try to figure out what number can go here to balance. So 18 minus the 6, that gives us 12, which means somehow I need a number here times 2 to give me 12, and that will be 6. And so we'll place that up. And then you're balanced. So what I'd like you guys to do now is go into 5.3 homework, and you're going to work on part 1. If you feel that you can handle this and you want to go through the rest of the notes and try out part 2 of your homework, feel free. And then again, I will be there tomorrow on Friday to go over any questions you guys still have. Appreciate you.